Hi, welcome back to my channel. My name is Gina. In this video, I'm going to teach you how to find the 100th derivative in a minute. We are going to look at 3 examples. Let's start with the first one. So usually when we want to find a really high order of derivatives, we need to write down the first 2 to 3 derivatives, then find a pattern. In this example, y equals to e to the power of k times x, where k is a constant. So let's start with finding the first derivative, dy over dx. We use chain rule. The outer function here is the exponential function, and the inner function is kx. And derivative of outer function is the same, so e to the power of k times x times derivative of the inner function. And derivative of a constant times x is the constant. So the first derivative is k times e to the power of kx. Now let's find the second derivative. So we take the derivative of the first derivative. The first derivative, we have a constant in front, so we just put the constant outside of the derivative, then times derivative of e to the power of kx. So similarly, derivative of outer function is the same, times derivative of the inner function, which is k. So the second derivative is k squared times e to the power of kx. Now let's find the third derivative. So the third derivative is the derivative of the second derivative. So we take the derivative of k squared times e to the power of kx. So similarly, we use chain rule of the exponential function, and derivative of kx is k. So we'll end up with another k in front. So third derivative is k cubed times e to the power of kx. Now can you see there's a pattern? Let's write down the equation for the nth derivative. First derivative, we have k times e to the power of kx. Second derivative is k squared times e to the power of kx. And third derivative is k cubed times e to the power of kx. So the nth derivative, it would be k to the power of n times e to the power of kx. So that is an equation for nth derivative. Now how about the 100th derivative? So using the equation we just found, the 100th derivative would be k to the power of 100 times e to the power of kx. Let's look at the second example. Similarly, we want to find the 100th derivative. And we need to write down the first 2 to 3 derivatives and then find a pattern. Here the function is x times e to the power of x. Let's find the first derivative, dy over dx. Here we have a function of x times another function of x. So we need to use product rule. So derivative of the first function times the second function plus the first function times derivative of the second function. So first derivative is e to the power of x plus x times e to the power of x. Now let's find the second derivative. Here we have 2 terms, so we use the sum rule. Derivative of e to the power of x is the same, then plus derivative of x times e to the power of x. And we just found that from the first derivative, that derivative of the second term is e to the power of x plus x times e to the power of x. And we can rewrite this as 2 times e to the power of x, so we combine the first and the second term, then plus x times e to the power of x. Now let's write down the third derivative. Here again we have two terms, so we use the sum rule. Derivative of the first term is 2 times e to the power of x plus derivative of x times e to the power of x. And from the first derivative, we found that this is e to the power of x plus x times e to the power of x. And again, we can combine this with the second term. So the third derivative is 3 times e to the power of x plus x times e to the power of x. Now can you see the pattern? Let's write down the nth derivative. We will get n times e to the power of x plus x times e to the power of x. So, the 100th derivative is 100 times e to the power of x plus x times e to the power of x. Now let's look at the last example. Here we want to find the 100th derivative, and we also evaluate the derivative at x equals to 2. So similarly, we are going to write down the first three derivatives. Here the function is x times ln of x. So derivative, the first derivative, we use chain rule, it will be 1 times ln of x plus x times derivative of ln of x is 1 over x. Let's rewrite this as ln of x plus 1. Now let's write down the second derivative. So we take the derivative of the first derivative. We get 1 over x plus 0. Then the third derivative will be derivative of 1 over x. 1 over x is the same thing as x to the power of negative 1. So its derivative would be negative x to the power of negative 2. If you couldn't see the pattern from the third derivative yet, then just take few more derivatives. Let's find the fourth derivative. So fourth derivative is derivative of negative x to the power of negative 2, which is 2 times x to the power of negative 3. How about the fifth derivative? It will be negative 6 times x to the power of negative 4. Now can we write down a pattern for nth derivative? This example is a bit more complicated. So there is the sign that is alternatively changing, and there is also the constant in front of x and the exponent to the x. Let's start with the exponent because it's easier. For the second derivative, exponent is negative 1. Third derivative, the exponent is negative 2. Fourth derivative, exponent is negative 3. And fifth derivative, the exponent is negative 4. So the exponent is always the negative of the nth derivative minus 1. So the exponent would be negative n minus 1. Now let's look at the sign in front. For the second derivative is positive. Third derivative is negative. And for the fourth derivative is positive again. And fifth derivative is negative. So the derivatives are positive, but n is even. Derivatives are positive for second, fourth, sixth derivatives. So how can we write that? We can write that as negative 1 to the power of n. So when n is an even number, then the negative sign will cancel out, so we'll end up with positive 1. Now how about the constant in front? For the second derivative, we have 1. For the third derivative, we also have 1. For the fourth derivative, we have 2, which is 1 times 2. And for the fifth derivative, we have 6, which is the constant from the fourth derivative, times 3. Here we can use a notation that is called the factorial. So just a side note, 0 factorial is 1, 1 factorial is 1, 2 factorial is 1 times 2, 3 factorial is 1 times 2 times 3, and it keeps going. N factorial would be 1 times 2 times 3 until times n. So using this, we can rewrite the constant in front. Second derivative is 0 factorial. Third derivative is 1 factorial. Fourth derivative, the constant in front is 2 factorial. And for fifth derivative, it's 3 factorial. So it's always the nth derivative minus 2 factorial. Now we can put the constant back. So for the nth derivative, the constant in front of x is n minus 2 factorial. And this is only true for n greater than or equals to 2. Now let's use this formula to write down the 100th derivative. The sign in front, since n is an even number, 100 is an even number, so we'll have positive. Then the constant in front will get 98 factorial times x to the power of negative 100 minus 1. That is negative 99. So if we evaluate the derivative at 2, we'll get 98 factorial times 2 to the power of negative 99. And that is the end of the video. If you like my videos, please like and subscribe, and I'll see you in the next video.